Today I'm going to show you what's inside of an automatic transmission and how it works to change the gears on your car. The automatic transmission is responsible for transmitting power from the engine through the torque converter, which mounts here, to the output shaft, which is your drive shaft that goes to turn your wheels. Now the transmission will change gear ratios to optimize engine performance and efficiency based on the driver's input through the throttle. Now some of the basic parts of a transmission include the kickdown cable. We've got your dipstick here, your two coolant lines that go out to the radiator here, as well as your park neutral switch at the bottom here, and the solenoid. At the back here we have your input and output shafts for your torque converter, and then we have the output for the transmission, which is actually your differential. And then we've got your speed sensor over here. Now the main components in the transmission start with the torque converter, which rotates with the engine, and that drives the oil pump, which sits on the front of the transmission case. Now inside the transmission case is the guts, which is your planetary gear sets, and then we've got the valve body that controls all the hydraulics for that, and finally we have the output, which is the differential that goes out to the axles to turn the wheel. Now this is the manual rod that gets controlled by the shift linkage in your console. I'm going to remove this nut over here, and then we have the park neutral switch that I'm going to remove next. And this is what the park neutral switch looks like. It's now with the transmission flipped upside down. I'm going to remove 18 10mm bolts that go across the circumference. Now I can remove the tranny pan. Now this here is the oil strainer. I'm going to remove the 3 10mm bolts that hold it on. And remove the oil strainer. And now the strainer has this filter-like material on the inside here. And now inside of the valve body we have 3 solenoids, and we've also got this cam here where that kickdown cable attaches to. Here we have the mechanism that changes the gears. You can see we've got these little teeth here that bounce on this spring, and that pushes this piston in and out. Now I'm going to remove the manual detent spring. Next I'm going to remove the valve body, which is this entire assembly here. There are 17 10mm bolts that I'm going to remove. Now I'm going to remove the valve body from the transmission housing itself. So far inside of the transmission you can see this is the housing where all the clutches are held. You can see a clutch band over here, and we've got some friction clutches over here. Over here we've got a couple of pistons that control all of that. You can see that there's fluid coming out. We've got a little check valve ball here, and then we've got the manual selection for your gears. Now I'm going to remove the pistons here. Now the pistons are essentially a little cylinder that has these 2 seals on it along with 2 springs. Now I'm going to remove the manual lever. Now this side of the transmission is called the bell housing, and that's just because of its shape where it connects to the engine. I'm going to remove 17 12mm bolts that go around the circumference. Alright, and now I can lift off the bell housing. So I've actually disconnected the oil pump with the bell housing, but that's what that looks like when it's separated. This here is the differential, and the CV shafts will connect to it on the inside here. It's situated near the back of the transmission on most front wheel drive vehicles, and I can just lift it off right here. You can see it's actually a part of the transmission as opposed to a rear wheel drive vehicle where it's out back. Now the purpose of the differential is to allow a difference in wheel speeds between the left side and the right side wheels when taking a corner. Inside the differential housing is the speed sensor, and it's got this little gear on it that rides up on this plastic gear that's hooked up to the differential. Now it will send an electrical signal out to the ECU in order to tell it how fast the car is actually going. This here is the little tooth mechanism that it engages with this final drive gear before it goes to the differential, and that will lock the transmission into the park gear. So you can see when the lever chucks down, it will lock this gear into place. Now this set here is called the direct forward clutch, and it's controlled by this band around here, which is called the second coast brake, and that's controlled by this piston inside of here. Now this piston gets its hydraulic fluid from this little line here that comes from the valve body, and that moves this piston up and down, and that will squish against this clutch here to stop it from moving in order to change gear ratios. So in order to get this piston out, there's a little snap ring I'm going to remove. So I've got what's left of my brother's musty old underwear. I'm just going to use that here and then bring in some compressed air to remove this piston. And that's what it looks like. Now I can remove the direct clutch with the forward clutch from the case. Alright, and if I can lift off this clutch here, you can see that this outside part is where the band clamps and it holds it steady. But on the inside here we have a bunch of these clutches that's free to rotate with the outside of this clutch over here. In order to remove this clutch band, I'm going to remove this little pin here, and then the band can be removed from the tranny. Next I'm going to remove the front planetary ring gear. Now I'm going to remove the first planetary gear set. Next I'm going to remove the sun gear. So next we've got a snap ring that goes around the outside here. I'm just going to use a screwdriver. Now I'm going to remove the second brake drum. So now I'm going to remove the series of discs and plates, and now we'll remove the flange here. Alright, now I'm going to remove the rear planetary gear set. Next I'm going to remove the 13 bolts for the rear cover. With all the bolts removed, I'm going to give this a tap with the hammer. With the cover removed, we have the intermediate gear here and the countershaft gear over here. Now I'm going to use a 36mm socket to remove these two lock nuts. And now I can remove that intermediate shaft. Back on the driven gear, I'm just using 2 bolts here to drive this pulley off of the shaft. Just pull it straight off. Alright, and now I can lift the transmission case off of the driven gear clutch and remove it from the transmission. You can see on the surface here we have this thrust needle bearing on the outside, and then we've got a roller bearing on the inside. So here I've got the guts of the automatic transmission laid out here so you can see just what it looks like from the case. Over here we have the input shaft, and that goes to this clutch on the inside here. Around it we have this drum, and that's controlled by this direct band clutch over here. Over here next we have a planetary gear set, which you can see inside of here. Then we have, of course, the sun gear on the outside, a one-way clutch, and the secondary planetary gear set over here. Moving on now, we have another set of clutches here and here before it goes out to the output shaft on that side there. Now the output shaft will drive a counter shaft, which is on the opposite side here, and that houses a bunch of clutches, a one-way clutch, and then another planetary gear set that is your underdrive gear set before it goes out to the differential here and then to the axles before it turns your wheels. Now we're going to take this planetary gear set here and open it up to explain just how you're able to get different gear ratios in your automatic transmission. Now the planetary gear set consists of 3 main components. Over here we have the ring gear, and that's because it's shaped like a ring and it's got internal splines on the teeth. Then we have the planet carrier that has these little planet gears on it, and then when you put that inside of here, you can see that it rotates inside of the ring gear itself, like that. And then in the middle here, we have the sun gear. Now when you place the sun gear inside of here, it's as if the planets are rotating around the sun, and that's why you call it a planetary gear set. Now the way planetary gear sets work to achieve different gear ratios is by holding one of those 3 components steady and using the other 2 as your input and your output shaft. So for example, if I'm to put this thing together, I'm going to hold the planet carrier steady, and then I'm going to use this shaft here to connect to my planet carrier on the inside. And then I'm going to rotate the sun gear as my input gear, and watch as the ring gear on the outside here, if that's my output gear, rotates. You also notice that for more that I rotate the sun gear, the ring gear doesn't move as much, so there is a torque increase or speed decrease there, and we've also got it moving in the opposite direction. So in this case, this gear ratio would be ideal for a reverse gear with a torque multiplication and a reverse motion. Now most automatic transmissions will use multiple planetary gear sets in order to achieve different gear ratios. So you can see we've got the first planetary gear set, and we have the sun gear, which is shared between the 2 planetary gear sets, that controls the secondary planetary gear set in a series motion. This 4-speed automatic transmission has a total of 3 planetary gear sets. Now you might be asking, how does the transmission stop one of those components from moving so you can have your input and output? Well, the answer to that is using clutches. Now this type of clutch here is a pressure clutch, and it consists of the piston itself here. Then we have a return spring, and then we have these series of bands here. Now if you notice, the metal bands have the ridges on the outside, and that will lock into the transmission case, and this does not rotate. Then we have a friction band here, and this locks to the planetary carrier in this case. It has teeth on the inside. When this clutch is disengaged, we have a little gap of fluid in between the clutch plates and the metal bands, and that allows the clutch plates themselves to rotate in the fluid freely so that this planet carrier can actually rotate. The metal bands on the outside are still stuck to the case, but now when you apply this clutch, it will actually squish together and become one piece. And that will lock the outside of the case to the inside of the planet carrier and stop it from rotating altogether. Now the way the clutch is pushed together is through this piston here, and that's controlled from the valve body through hydraulic pressure. You see, transmission fluid will enter this little hole here, and that will cause this little piston to push up, and that will squish these clutches together, causing them to engage and become one piece to hold this planetary gear. And now once your planet carrier is held still here, we have the sun gear in the middle as your input, and then we have the ring gear here as your output, and that's how you achieve different gear ratios. Now the second kind of clutch is called a drum clutch or a direct clutch, and that usually controls second gear. Here we have a band here that will go around this drum, and then we have a piston that we saw earlier in the case that will actually squish this band here to stop this drum from rotating, and that can change some combination of the gear ratios following this. Now inside of the transmission there's a series of these one-way clutches, and that only allows rotation in one direction, but it locks in the other direction. Now this here is the valve body of the transmission. You can see this here is where the throttle cable will connect to, and it essentially is a bunch of valves and passageways that actually control the motion of the transmission and tell it when to shift by directing hydraulic fluid to the correct places. Now I'm going to open up all these bolts to see what's inside. Alright, so if I pull off the top of this cover here, you can see we've got some kind of a gasket material, and then we have what looks like a little nest or a little maze inside of here where there's a couple of valves located. We've also got these little solenoids on the side here that are electronically activated, so the computer can direct fluid inside of the valve body to tell it when to shift. Now what's really cool is that this maze actually has 2 floors. So if you open it up on the bottom, you've got another maze on the bottom, and if you look closely you can see that there's these little check balls, and there's sometimes springs inside of here. See all of these little balls? And that's just to prevent fluid from moving one way or the other. So you can see inside the main floor of the valve body, you've got a lot of little rooms and spaces and channels for transmission fluid to flow depending on what gear you need to be in. We've also got these little valves here, and what they do is they redirect the pressure according to where it needs to be or which clutch it needs to lock up. So you can see as I move these little valves here, that will redirect the flow of the fluid to a different location to lock up whichever clutch you need to be in that gear. Now on the basement level of the transmission we have the throttle valve here, and that actuates this little cam that pushes this valve in and out. How this works is it's basically fighting fluid pressure that's coming from the pump compared to the pressure that you put on the throttle through this cable here to tell it which gear to shift into. So for example, let's say there's a slow Corolla on the left lane and you need to take up and pass him. Well, you're going to press the throttle pedal and that will push this valve in. It will downshift it to second gear because all of the fluid pressure will be redirected to those appropriate clutches. Now when you release the throttle, the valve will move back and the pressure from the pump will actually overcome that valve and go and shift into third gear so you can cruise along. Now most modern vehicles don't use a throttle cable, everything is electronically controlled. Now the transmission fluid pump is responsible for creating fluid flow inside of the torque converter as well as inside of the transmission so it can shift gears with the clutches and lubricate all the moving components. Now the fluid pump is driven by the torque converter, which is spun by the engine, so it always rotates with the engine. Now I'm going to remove all the bolts on the back of this pump to see what's inside. Now if I remove the cover off of the oil pump here, you can see this is what we have. Now inside of this oil pump is essentially the same as the oil pump in your engine. It's got this internal gear that rotates inside of here, and how that works is we've got the input fluid that comes here and it gets compressed inside of here because this creates a low pressure zone and is essentially squeezing the oil in between these 2 gears here before it exits here. So you can see basically it's creating fluid flow, not fluid pressure. On the back of this thing here you can see we've got the input channel and then the output channel where the fluid will come out, and then on the housing here you can see that that correlates to an output on the outside here where it will go into the valve body and the rest of the transmission. Now if we have a look inside of the automatic transmission, you can see these are the ports here that come from the oil pump that will take fluid flow directly to the valve body to be redirected. Inside of the case here is where the 2 main planetary gears live, and we have their clutch packs that will brace up against these little notches inside of the transmission, and these clutch packs are controlled by these little hydraulic passages that come from the valve body that instruct the clutch to lock up when you're changing gears. Now inside of the bottom of the case of the transmission, again you can see that there's a lot of little holes and ports where hydraulic fluid can move to different components inside the transmission. We've also got these pistons inside of here, and what they do is they act as accumulators to buffer the closing and opening of a clutch so that it's nice and smooth to engage and disengage gears. You see, automatic transmissions are much like human beings. We have the oil pump here, which is the heart of the transmission that moves the fluid around. Then we have the valve body, which is the brain of the transmission that's directing the transmission's guts, which are the gears here that actually determine the gear ratio. And that's pretty much all the components that go into making your automatic transmission work on your car. Now try putting it all back together.